Good morning, my friends. I'm Clover, and this is Genuinely Approachable Sudoku, and today we are solving All is Forgiven by Philip Newman. This is a killer Sudoku. That means we're placing the digits 1 through 9 once each in each row, each column, and each outline 3x3 region. And then there are also some killer cages in the grid. And in those cages, digits can't repeat, and they have to sum to the indicated clue in the top left corner of the cage. So we're going to start with some cages that are kind of given already. So we have 3, which is always 1 plus 2. 17 is always 8 plus 9. 4 is always 1 plus 3. And 16 is always 7 plus 9. And I actually found it easier to start on the bottom when I was first solving this. So 11, if we can't use 1 and 3, look at the minimum there. 2, 4, and 5 already sums to 11. So that has to be 2 plus 4 plus 5. And that makes the last 5 digits in the row 6, 7, 8, and 9. But because we've already used 7 and 9 in this region, we eliminate them here. 8 can't have an 8 in it. So that's a 6 plus 2. This is going to be an 8. If 14 had a 7 in it, it would be 7 plus 7. That would be a problem, so that must be a 9 with a 5. And that's going to be a 7 with a 9. Now, 5 eliminates 5 from these cells. And now if we look either at the region here or the row for this 12, we can't do 5 plus 7. We can't do 3 plus 9. It must be 4 plus 8. And that leaves the digits 2, 6, 7, and 9, and only 2 of those digits can be part of a sum of 9. That's 2 plus 7. Okay, 8 plus 9 there makes this a 4, and makes that an 8, and we have a 9 there, which resolves that 6 and 9. These are now going to be 1, 3, and 7, and that can't be a 7. And now if we look at this, we have 14 here. Then we have a 2 and 4, which is 6. That gives us a total of 20. And then we add 17 to that. That gives us 37. Now, all 9 digits together in a Sudoku make a sum of 45, and 45 minus 37 is 8. So the remaining 2 digits have to sum to 8. How do we do that? That is going to be 1 plus 7. That makes these 3 digits, 1, 4, and 5, and these digits 3, 6, and 8. Okay, now if we look at the top, 12 without 1 or 2 has to be 3, 4, and 5. Once again, similar to the 11 down at the bottom, that's a minimal. And then these are 6, 7, 8, 9. That can't be 8 or 9. 7 can't have a 7 in it. That's a 6, that's a 1, and that's going to be our 7. So now that's 8 or 9, so that is 6 or 7. Okay, now that we've placed a 6 and a 1 here, that has to be our 3 and a 1 over there. So the next thing I did, and this might not have been the best move, is to look at this 5 cage. We can only use digits of 1, 2, 3, and 4. This one can't be 1 or 4. This one can't be 1 or 3. So it's got to be 2 plus 3 in that order. So that actually worked out a little bit more cleanly than I remembered it working out the first time I solved this. So maybe that is the right next place to look. So these are going to be 2, 3, 4. That's not a 2 or a 3, so that's a 4. That makes these digits 5 and 9, and these digits 1, 4, and 8. Now that 2 there resolves the 1 and the 2. And so now if we look at this 6 cage, that has to be either 1 plus 5 or 2 plus 4. And it can't be 2 plus 4 because neither of the digits in it could possibly be 2. So it's 1 plus 5, which goes like that. And that resolves this 1, 4, and 5. Now these digits are going to be 3, 4, 6, and 8. So now how do we make 19 out of these? We already have a 5. So the remaining 2 digits have to sum to 14, so they're going to be 6 and 8. Now we can't put a 3 in a 2-cell 13 cage, so that's going to be our 4 and a 3, making that a 9 and an 8. 3 and 4 in the region gives us a 5 here. The 4 there gives us a 3 and a 4. And the 4 also resolves this. I like that we still don't quite know how that works. In fact, we're not going to figure that out until right now. So the 9 we placed in the 13 cage resolves this, which gives us an 8 here and a 7 here. So now these are going to be 2, 3, and 5, and 6. That can't be 3. That can't be 5. That can't be 2, 3, or 5, so that's a 6. So these digits are 1, 6, and 9, and that does check out. 1 plus 6 plus 9 does equal 16. These are going to be 2, 4, and 9. And these are going to be 3 and 7, which resolves. That can't be an 8. The 7 I've placed in the second row resolves this. These are from 1, 6, 8, and 9, and that's not 1 or 9, so that's 6 or 8. Now, this is a cute little trick. If this was an 8, it would force this to be a 6. And that would make the sum 14 already, but because the total sum can only be 13, we know that can't be an 8, so that is a 4. Now 4 plus 8 is 12, which would make the last digit 1. We've already used a 1. That's a problem, so it's got to be 4 plus 6 plus 3. That can't be a 6, so that's an 8. Okay. 3 that I've placed there gives me a 6 and a 3. And the rest of it should just resolve with a classic Sudoku. And that's how you solve Philip Newman's All is Forgiven. Hope you guys liked that one. The link to solve it yourself is in the description of this video, and I will see you again in 3 days.